Howdy folks, welcome back for another Feature Friday. I'm your host Ryan Glover, and this week we're going to be talking about building a job server. So I've been kind of losing my mind the last few weeks, as you know. I've been trying to scale a feature that I started about 2 months ago now, maybe a little bit more than that at this point. And the problem I was having, so the feature is to help customers of my app command the SaaS that I've been working on the past few months. It's designed to help them track the revenue of their own product. And so as a part of that process, I need to download some data from a third-party payment processor. So right now, the only one that I'm supporting is Stripe. So I have to download some data from Stripe, and then I need to run calculations on that data. And just based on the nature of the data that I get back from Stripe, as well as the nature of the calculations, every single time that I want to update the calculations to the latest value, I need to run them from start to finish. Meaning I need to calculate a running total so that way historically the data is correct. That's all well and fine, but the problem is when it comes to trying to do that type of work on Node.js, it kind of bogs down the system and then things get slow and then it takes a while. So I want to say that I mentioned this in a previous video. The problem I was having was everything would work, but it would take, for small sets of data, it was pretty quick. It was a couple of minutes. But for big sets of data, it was like 2 hours, 3 hours, 4 hours, and sometimes it never even finished. It would just kind of sit in a loop. And so after a bit of thinking, I realized, well, I need to offload this work to something else. So if you watch I think it was the past 2 videos, we talked about using cloud functions. And that idea was sounding great. It was sounded like a really smart way to go up until, like I mentioned in the last video, I ran into a timeout problem. So the task that I'm doing it's kind of inherently going to run for several minutes. I don't know how many, and the reason I don't know how many is because it depends on the amount of data of the customer that's connecting their Stripe account. So if they've been in business for 3 months, not a big deal, but if they've been in business for 10 years, kind of a problem because it's going to take that much longer. It's just that much more data to work through. So the timeout issue in the cloud functions kind of thwarted me. I got in this position where I had it working there, but because I didn't have enough time to run the function, I was kind of screwed. I was trapped. So the final solution, and thankfully this is one that has not only worked, but it kind of showed me some opportunities for speeding up the code and improving the code, is to build a job server. So a job server may sound like something really fancy, but all it is it's a separate server, and that server is going to take in requests and then process those requests. So just like our regular application, but the separation is that server's responsibility is only for processing jobs. It's not also handling traffic from users trying to load their dashboard or update their profile or talk to their own customers. So some of the features that I have planned for Command. It's not going to handle any of that stuff. It's only going to handle heavy lifting. So if you imagine us having some sort of robot that lifts packages for us, we're just going to hand it a package and it's going to lift it and put it on a shelf for us. Kind of an abstract way to think about it, but hopefully that makes sense. So what I want to do in this week's episode is kind of walk you through how I set this up and why I made the choices that I made, and also how you can scale your own application using a pattern like this. Now, before we really get into it, I have to stress, you may not need to do this. So don't take this as the gospel and me saying like, well, yeah, everybody needs a job server. No, that's not the case. So the reason I needed this job server is because it solved the problem. I wouldn't have gotten here unless I knew that, okay, this was going to help me do what I needed to do. So before you really move forward with building something like this, consider if you really need it. And I'll kind of explain as we go here how I knew that I needed it and how you can kind of inform your own thinking to know whether or not this is absolutely necessary. But regardless of all of that, it's still good to know how this stuff works. So the root of what I'm doing, so let's go ahead and start over here in the actual server.js file. So what I decided to do, and if you haven't been watching these, the application that I built is built with a boilerplate that I maintain called pup, and pup is based on Meteor.js. So technically that's a Node.js app, but it's got all sorts of conventions introduced by Meteor. And that application is right here. So I've got both of these kind of open into my IDE right now. So the application is based on Meteor, but for the job server, I wanted to keep things as lightweight as possible. And so what I decided to do is just build my job server as a regular Node.js app. Now, if you have experience with Meteor and all that stuff, that might sound a little scary, but honestly, it's not too crazy. So the big difference between the core application and this job server is the way that I'm writing my code. Now, technically, I don't have to do this, but this ended up being a time saver, and it allowed me to reuse a lot of the code that I wrote for the cloud function, which is, you'll notice, instead of a lot of import statements, I'm using these require statements. So the big difference here is that require is just the default way that a Node.js application is going to handle in import. So that's it requiring another file or requiring another module. The import syntax is new to JavaScript. So that's, I want to say it was ES6 and beyond. So basically, with all of the new JavaScript stuff, the import and the I want to say they call it the module syntax or the module system. Don't send me hate mail. You'll know what I'm talking about. But basically, the difference being, if I were to say like import, what's on here? So path from path. So this line here is equivalent to this line here. It's just a different way to do it syntactically, and means that you just have to do it a different way. So the big difference here being that this application doesn't support the import statements because I'm not using a system like Babel. So if you haven't heard of Babel before, that's a compiler, transpiler. I think they've changed the name a few times as to how they refer to it. But basically what that does is it takes some code, or more specifically, it takes some new JavaScript code, and it compiles it into JavaScript code that's going to work. So the translation that it's making is from ES6, 7, 8, and beyond back to ES5. So it converts the concepts so that they're going to work with older browsers or older servers. So that's the basic move at play here. Now, I was going to do all the Babel stuff, and then I said, like, you know what, it's not worth it. I'd rather just reuse the code I wrote for the cloud function, which is tethered to this kind of require syntax that you can't really get around that. So that's where I'm at. That's what we're doing here. So beyond that, most of this stuff is the same or should look pretty familiar. This is just like what we would do in a Meteor app or a Pup app. The only difference is we don't have all the Meteor goodies that we'd be used to. So the core of what I'm doing is using this library right here, Express. Now, if you've been working with JavaScript for a while, I'm sure you've heard of it. Express is just it's called a web framework, but really it's just a way to quickly spin up an HTTP server. That's it. So what I'm doing inside of this file is, and this convention here, this is just me creating the instance of Express, and then all of these. So you can see I've got app.use a few different times. This is equivalent to us defining a route using something like React router that we have inside a Pup, or on the server side, if we were using Meteor's built-in web app package. It would be the same exact thing, just a different way of doing it. So the idea here is that what I'm trying to do is process HTTP requests. So keep in mind, the job server is completely independent and runs completely independent of the main application. So in order for those two to communicate, I have to have a channel to communicate over. And so the channel that I've chosen is just a regular HTTP request. So when I want to schedule a job or send a job to the job server, I'm going to send an HTTP post request to the job server, and then the job server is gonna handle the work that it needs to do. So the way that this is working is, first and foremost, once we have our application instance, I've got a little bit of middleware here. Now, this one is very good to know about. So you'll notice I'm talking about Stripe here, and it kind of hints at webhooks. So what I also did was I moved the sending of webhooks that I get from Stripe. And webhooks are the events that occur on Stripe that I don't know about yet, or the application doesn't know about yet, but I want to handle them in some way. So this means when a customer of mine has done the initial import, so they've imported their data from Stripe for the first time, and then they haven't touched it, but there's still activity on their account, I want to know about that activity. And so what webhooks allow me to do is get updates from Stripe automatically when that activity occurs. So literally, maybe say they get a new customer, they get a new subscriber for their SaaS app. Stripe is going to process that, create the subscriber on their end, and then a webhook allows Stripe to say, oh, hey, other application, this thing happened. And so they're going to send me a webhook, and what I've done is I've pointed it away from the application, meaning I've pointed the URL that Stripe is going to use to send the webhook away from the application to the job server. So what this code is doing here is it's saying that, well, based on the way that Stripe handles the authentication of the security for their webhooks, I need to get the HTTP request body, so literally the data that's being sent from Stripe, I need to get that in a raw format. Whereas the rest of the information that's coming into the job server is going to need to be in a JSON format. So you've got kind of like plain text versus something. So like this would be your JSON object. This would just be like the plain request body. So the way that I've set up my middleware, and middleware does kind of what it sounds like. So it sits in the middle of a request. So you've got the life cycle of requests get sent to the server, server gets the request, server runs the request through middleware, and then finally passes whatever the result of that run through the middleware is onto the resulting URLs that you support. So onto these app.u/jobs. And we'll come back to all that stuff. But the point here is that because we have two different types of HTTP body that we need to support, what I have to do is define a middleware that parses those two different types. So what I've done, and this is a personal convention, this is something I just whipped up to handle this in the least frustrating way possible. So what I realized was when I get one of those webhooks from Stripe, they include a user agent. And generally speaking, most APIs that you access are going to be assigning a user agent. So the user agent is literally telling you where is this coming from, at least in part. So what I've done is I said, well, if the user agent, so you can see here what I'm saying is, get the request.header. So your user agent is always going to be in the headers of the request. So I'm saying from the request headers, give me the user agent, and we want to check to see if that user agent that we get is in this array. So I've defined user agents requiring a raw body. So right now this is just Stripe, but I've designed this so that maybe later if somebody else needs this for some reason, I can quickly add their user agent and be done with it. So this is saying if Stripe's user agent, and this isn't anything that I've defined, this is something that Stripe has defined. So this is literally what they send in the user agent header. So if that header, Stripe/1.0, and then that URL are in the user agent field, then I know that, okay, that's somebody who needs to return the body, the HTTP body, as raw data. We don't want to convert it to anything. So that's what's going on here, is I'm saying, okay, if this test passes, go ahead and take that data and run it through body parser raw. Now, I want to say we've come across body parser before, but if that doesn't look familiar, body parser is a package that allows us to, surprise, surprise, parse the HTTP body that we get from a request in a number of different ways. So again, we have raw, so we just want to leave it alone. And then we have JSON, which means convert the body to JSON objects. So what's going on here is I run it through whatever that parser is, but the way that the body parser methods are defined, so when I say methods, I mean .raw and .json, the way that those are defined is that they are expecting to be called as a function and passed a request, response, and next. So I don't think I have anything else in here. So let me whip this up. So generally speaking, when you hear about middleware or somebody documents how to use their middleware, it won't look like this. This is a special case because I have to do this check before I decide which middleware to use. But traditionally, and technically this is how this looked before, what I was doing is I was just passing body parser JSON like that. So technically this line here is equivalent with this line in terms of behavior, but how I'm running it is a little bit different. So notice that I have app.use just the same, but I'm passing a function to app.use first. And that function is taking in request, response, and next. And those are the values that Express gives to me when I'm trying to define a route. So the way to think about this is that this code right here is like a catch-all. So every single request that passes through the server is going to pass through this function first. And so because of that, Express is giving me access to the request, the response, and then next is a function that I can call to say, hey, the work is done here. You don't have to do anything else. So what I've done is I've just passed that function as is, but then inside I've said, okay, run this logic, and then based on that, I know that I want to call one of these methods, so bodyparser.raw or bodyparser.json. And so what's happening is, again, if you look right here and compare that line with this line, the idea is that, go back, the idea is that what's happening is app.use expects a function to be passed that it can call. So this is like a traditional callback function pattern. So the callback function here is very explicit. We know what it is. The callback function here, we don't really see it, but we can trust that based on the design of that body parser package or the design of its methods, that it's going to return a function that expects us to pass it request, response, and next. So bodyparser.json is, hopefully this isn't incorrect, but I think it's maintained by the Express.js folks. So it's designed to expect this information in this exact order. So what I did was I said, okay, well, if it expects a function to be returned, and then that function is going to expect values to be passed, what I do is say, call the function, and then because I expect this chunk to return its own function, I know that, well, I can just call it like any other function, and then pass in the data or the parameters that it would expect. So that's all that's happening here. So again, the difference is every request comes in. If the user agent is in this array, so in this case, if it's Stripe and it's the webhooks user agent from Stripe, then I know I want to parse the data as raw. Otherwise, I just want it as JSON, and then we keep going. So that's part one, and that's arguably one of the more tricky parts of this, but it's important to know about that because I wasted an afternoon trying to get around all those headaches, so hopefully you benefit from that if you ever do it. And I'll explain a little more either in this video or maybe we'll do another one depending on how long this goes, why specifically I need that in raw from Stripe. So I'm thinking if there's anything else here. Okay, so little details. So like this limit 50 megabytes, that's just me making sure that really large objects that I might get from Stripe or somewhere else or from my own server aren't going to be blocked. That I might tweak. That was just taken from an example that I saw where somebody was getting their request blocked, and they just said, just ratchet it up to 50 megabytes. So I might change that just to make sure that I'm not getting random payloads sent to the application that are relatively large, but for now I'm just going to go ahead and leave that alone. So the next thing, again, another piece of middleware. So this favicon function is just this serve favicon package. So this is recommended by Express for, again, surprise, surprise, serving your favicon. So one of the things that trips you up when you first start working with a vanilla server like this is you're getting requests from the browser. You're getting multiple requests. So if I type in the URL localhost, so I'm running this on port 4000. So if I say localhost 4000/jobs and in the browser and then I hit return, what happens is the browser is designed to make a request for a favicon as well as the get request, so me requesting whatever the URL was that I asked for. And so we need to account for that. So all this is doing is making sure that that request for the favicon from the browser doesn't break the code that you're writing, because if it takes in that URL, it's going to be like, favicons not defined, and it can send the whole house of cards falling down. So all that's doing is making sure that when we get that request from the browser, it points it to this little favicon right here. So that's that. Now we get into the fun stuff, the meat and potatoes of this. So I'm trying to think, do we want to talk about, I think we're going to save the Stripe webhook stuff because we already have kind of covered that, but yeah, we'll loop back around on that. So, jobs. The way that this is working is not totally dissimilar from how we were handling the cloud function. So again, cloud function lives on a server somewhere. we need to send a request to that server and tell it what to do. So with a cloud function, it's a specific function. It's like literally just one function. Whereas right here, it's a little more open-ended. So just to kind of hint at what I'm talking about, this directory right here is the contents of the job server. And you'll notice I have another folder inside of that also called jobs, and that has a bunch of different folder names in it. So it's got calculate revenue from Stripe, handle GitHub webhook, handle Stripe webhook, import payment processor. So all of those are what I would classify as different jobs that need to be run. And if we look, the idea here is that the actual code that performs the job is in here. So it's on the job server. It's defined there and it lives there. So when it comes to triggering a job or performing a job, what I'm really doing when I send a request to the job server is I'm saying, trigger this function, and then I'm also providing some inputs that function is going to need. So if we look at this code, and I don't want to belabor it too much, I have reused quite a bit from the cloud function, so hopefully this looks familiar. But basically what I'm doing is I take in the request, and we got a little thing we can clean up there. So I take in the request, and I pull off the body. So here I'm just using ES6 destructuring to say pluck off the body from request. So this is the equivalent of request.body. So what I'm saying is give me the body, and then from that body I want to pluck off a job and an app token. So this is, I want to say I definitely did this in the cloud functions. So the app token, if you don't remember that, was how I authenticate that the request I'm receiving is from me or is from the application and not some random person. Because again, anybody can access these URLs on the web, so I need to authenticate that, okay, is this actually coming from me, or is this just some like random person on the other side of the world sending me junk data? So that's what this check is doing. Again, this is almost identical, I believe. Yeah, this is identical to what we were doing with the cloud function. It's just that the location of the data has changed. So I'm not going to show you the settings file. I'm going to reluctantly do this. I might have to black the screen out. Nice. Okay, so what I've done is I've got all of my different settings files based on environment. And so the thing that I've stored inside, it looks something like this. So it's literally like, I don't know. I've got my Stripe keys in there, and I know there's one called webhook secret, is what it's called. So this is like any other settings file if you've ever worked with Meteor or something like that. It's just a slightly different structure because in the Meteor application, that convention is handled for you by Meteor, meaning the loading of a settings file and the structure of a settings file, whereas here I've had to come up with this convention myself. And essentially what I've done is I've mimicked what Meteor does, so it's not terribly different from that. But the idea is that all of these different files contain the keys that I need for each environment, and then right here this code is saying, okay, let me, based on the environment, so I load the file names, so I just set them on this object, and then the one that gets chosen, or the settings that get chosen for the application, are based on one of two things, either the existing node environment, or right here I'm doing this is kind of funky, it says process.env.env. So the separation here is if I was just building this or running this as a regular Node application, meaning, let's see if I've got some stuff here. So if I say Node and then server.js, that's me running this as a regular Node application. And so I would expect my Node environment to be set there, or it could be set there. Whereas this part is a cover for something that we're going to look at in a little bit called PM2. So PM2 is a tool that allows you to run your Node.js server, but it also gives you a lot of fun little tools that you can use to supplement that process. So it gives you monitoring tools and ways to handle performance easily. Again, I don't want to go too much into that, but the reason I point this out here is that when I run the application with PM2, it stores my environment variables, or my current environment, I should say, not the environment variables. It stores my current environment, so like development, staging, or production, in this variable or at this path, versus a regular Node.js start is going to be through here. Again, we'll look at PM2 in a little bit here because that can be a little confusing. The punchline here is that whatever value gets set to this settings variable here, so again, that's going to match the property on the object, and then that's going to be set back here. I'm just exporting that from this file. So what that means Let's back this up just a few turkeys. Make sure I don't break anything. There we go. Okay, so what that means is when I'm inside of here and I require the settings module, I'm getting the correct one based on the environment. So it doesn't matter if this is pointing to the development app token or the staging or production, doesn't matter. It's going to be the right one because of the logic back here. This is going to ensure that I get the correct settings for the correct environment. So again, all this is doing is just verifying that the app token that they've passed us matches the one that we have locally on the server. So that means that, okay, this is a valid request. So if it's not a valid request or an app token isn't passed, we just say, that's a 403 forbidden error, and then we just say, make sure you pass your app token. So that's one. And then the next check is a little more sensible. So this is just saying, okay, if you didn't pass us a job to complete in the body, so literally the body has a property called job. If you didn't do that, that's going to be an internal server error. So we're going to say, hey, pass a job to complete, otherwise we can't do anything. And then the actual meaningful part of this, which I'm sure you're like, come on, just get to the point, is this goober. So queue job is designed to, well, queue the job. So if you'll notice here, the idea at play here is a job server is likely, once it's in production and you have an active user base, it's going to get a lot of traffic. So if you think about it like maybe if you've ever been to like a batting cage or something like that. So a batting cage is, they've got like this little machine set up that spits out baseballs at you and you can swing at the baseballs. Kind of fun. Except when the machine breaks. So the machine breaks and it just starts shooting 50 baseballs or softballs at you all at once. And this happened to me as a kid. It's kind of unfortunate. So you get hit by those balls and you don't know how to handle it. The job server is no different when it comes to requests. So if the machine breaks, or if we just have a high traffic load and we start sending all these requests over to the job server, it's not going to easily be able to handle that. Again, a server or a computer is just like you or I. It's a brain. It's something that has to process information. Now, it's a hell of a lot faster and a lot more efficient, but you still have to consider if you're having hundreds or thousands, or in some cases with some applications, millions of requests per second, you have to be able to handle those. So like we've discussed in other episodes with other parts of this application, what I've relied on is a job queue. So a job queue is exactly like you think. So if you go to a store and you're waiting to check out and you queue up or you get in the line, well, you got to wait your turn until the clerk can cash you out or can check you out with your items. Job server is the same way. So what we're going to do is we're going to queue our job to say, hey, take this job in, take the information that we're giving you, and then put it in line. So if there's a weird day where thousands of people sign up and they all trigger the same job at once, that's fine. We're just going to put them in the line, and then we're going to say, okay, we're going to wait until it's time for this job to complete. Now, like we've talked about in other videos, the way that we handle that in our UI is up to us, but the point being that we don't want to flood our server with traffic all at once. We want the server to be able to process stuff when it actually has the capacity to do it or the resources to do it. So queuing just makes it so that when we send a job over, we send a bunch of jobs over, they're going to be run in the order that they were received, and they're going to be run only one at a time or however many at a time we specify, again, based on server resources, and that's going to efficiently process without having to slam the server with a bunch of stuff, and then the end result being we drop jobs. So we don't want to do that. So a queue just makes it so that we can receive a bunch of data at once without losing the original intent, which is processing the job. So queue job here is pointing at this file right here. So you notice I've got inside of this jobs directory, I've got my queues directory, which has a bunch of different queues in it and this index file. So the best way to think about this file is it's kind of like so back in the olden days, if you're a kiddo, this is before my time, so like really olden days, they used to have this concept of a switchboard in a call center. So they would literally have humans sit in front of a board with a bunch of holes or slots, and when a call came in on one slot and somebody said, oh, I want to talk to this person, the way that you connected them was you would take a wire from one slot and you'd plug it into another slot. And so you were basically, it was called a switchboard because you're switching from one connection to another. And they were literally humans. So if you've never seen it, look up videos of an old switchboard room. It's kind of nuts how the human machine, as it were, was operating. It's kind of cool to watch. So the reason I mention that is that this is essentially what this file is doing. So this is saying, give me all the different plugs that I can send data to, and then based on the type of job that I get, I'm going to route the job into another queue. So again, there's no queue in this specific file, but rather the queues exist in their own file. So like if we look over here, we'll do payment processor imports. So this one should look familiar. I think we talked about this. So this queue is designed to handle all of the jobs for payment processor imports. So what that does is it runs through the mechanism of queuing the job, and then when it's time to run the job, it does all of this code and processes it. That part's not so important, but the part that is important is how this works. So I'm saying take in a job, and if I get one for import payment processor, I'm going to add it to that queue. Now that queue, depending on how much traffic it has at the moment, will handle that job when it has the resources to handle it. But up until then, I don't want to do anything with it. So adding it to the queue makes the most sense. We'll let the queue handle itself when it's ready. And so what's going on here is I say queue job, and again, job is an object. And so there's a little bit of a hint in this file in that when I send a job over, I'm going to include a type. So that type is saying this is the code that I want to run over here in the jobs folder. So if I say I want to handle webhook Stripe, or I want to import payment processor, well, that tells me exactly what queue to put that job in. Now, there's a reason for this. And this is a theoretical version, meaning it's something that, in theory, I think this is a good idea, or this will save me trouble later. We'll see if that pays out. The reason I did separate queues was because I didn't want to get into a situation where one job was failing or acting up or getting a lot of traffic and was being mixed or blocking all of the other jobs. And so by putting these in separate bins, I can do a few different things. So I know that, well, if there's a problem with that specific queue, I only have to worry about jobs in that queue or related to that queue failing or getting messed up. So that means it's a separation of concerns from the other queues. I don't have to worry about them getting messed up. Also, just high traffic loads. So if I have a bunch of traffic to one queue but not the others, the other queues aren't going to get blocked unnecessarily. They're going to, as soon as the server says, I have the resources to do this, that queue will just say, here, take this job. And if it's a smaller job, it'll just get done as quickly as possible, as opposed to having to wait on a job that's taking a little bit longer, which is always good. So there's that. I said few, like there's more than two, but I think that's it. That's the core stuff. But the point being that it's just separating concerns and reducing the load on the server and the amount of thinking that it has to do in one. So that's what this is doing. And again, that's the bulk of the magic at play here. So all I'm doing is I'm saying, go ahead and drop the job into this queue. So this creates the queue. And then I'm saying, go ahead and put the job in that queue. And then when it's time to process it, this function is called, and the job runs, and it does what it's supposed to do. Again, that's a rabbit hole, and I recommend going back and looking at the last few videos on running job queues and building this whole thing. I've been working on this, like I said, for about 2 months now, so there's plenty of material explaining what goes on internally in that stuff if you're curious. But the important part here is that, okay, we get up to this point and we run the job when it's time. Now, you may notice, and this is when we start to shift our focus to this PM2 thing. So I'm saying cluster.isWorker. And what I'm doing here is I'm saying, let's kind of collapse this so we can read it all at once. So I'm saying if the cluster is a worker, we want to process this job. And you're probably like, what in the hell are you talking about? So we haven't covered this yet, but this is super, super important. So Node.js is single-threaded, which means that Node.js, by default, can only run one thing at a time, and this is an intentional thing. So, by default, Node.js is designed to handle asynchronous requests, meaning you send it something, it thinks about it later, and then it calls a callback function to say like, okay, I'm done. I've put it into the call stack to handle later. So that's all well and good. So with things like we talked about webhooks, so a webhook is going to get passed to Node.js. We want to receive it, put it somewhere, and then immediately just say like, okay, we're done. So asynchronous requests are what are known as non-blocking requests. They're not going to block the thread. So just like we talked about our job server processing jobs in order, Node.js is going to do the same thing. So if you send it some job to complete or some task to complete, it's going to do it in the order that it received. And so when your code is asynchronous, that runs or that happens really fast because the code that's running isn't blocking the server, the thread. It's saying, just run this really quick, take care of it, and then when the job finishes, then call this callback function and tell me about it. Don't wait on the thing to process. So when it comes to synchronous code or blocking code, that whole thing is inverted. So you have this problem where if you need to wait on a piece of code, like in this case. So if we look for, where is it? So like right here, this is technically blocking code. I want to wait on import Stripe data until I go on to something else. And because I want to do that, I'm essentially blocking Node.js from doing anything else. It's literally, if you've ever heard the phrase one-track mind, Node.js is a one-track mind. So as soon as we block it or tell it to wait on something, it's going to literally wait on that one thing, and anything else you send to it, any other request you send to it, it's not going to do anything with it. It's not going to do anything. It's going to sit there and say like, okay, I put it in the queue, but you got to wait on me to finish this other stuff. So where that becomes a problem is with situations where you have a lot of traffic trying to trigger blocking code all at once, like this case. So where I'm importing Stripe data, I have to wait for that data to import because I have to get it and then run calculations on the data. So what that means is I can't run the calculations without the data. It's a chicken and egg problem. So I got to say, get the data from Stripe first, then run the calculations. So I don't have any choice but to block or to wait on that task. So that's fine, but the problem with Node.js is because it's single-threaded, that means I could technically only manage one of these at a time, which kind of sucks. And that really sucks because modern computers are actually really, really powerful. So if you've ever looked at the specifications for a computer these days, they've got this concept of multi-cores or multiple cores in their processor. So you have a CPU, but it's got a bunch of little processors in it. So each one of those is like a mini brain that can handle tasks. Now, again, by default, Node.js is single-threaded, which means it can only use one of those little brains by default or one of those cores by default. So there's this concept in Node.js that was introduced in the last few years. I don't remember the specific time range or the specific version, but this concept of clustering. So a cluster in Node.js is a way to take advantage of all of those multiple cores or those multiple parts of a processor to run multiple tasks at once. So that doesn't change the blocking nature of Node.js. It just gives Node.js more resources to work with instead of just saying, oh, just wait on this one chunk of the processor. We can spread the work out across the entire processor so that way it's a little more efficient. So the way that comes into focus is through this concept of a cluster. Now, Node.js, let's see if we can find the documentation. We can. So Node.js clustering is a concept built into Node.js. So basically, this is the way that it works. It's pretty simple in terms of how you set it up, but not always simple in terms of how it behaves. So what's going on here is you've got this cluster package, and that cluster package allows you to figure out what is it that I'm trying to, or what processor am I trying to split? So what happens is the cluster package wants a number of CPUs that are available. So CPUs are literally the cores that are available to a processor. So, and this is, you can see me kind of getting tripped up. I got to remember how this works. So you have your CPU and it's got multiple cores inside of it. And this OS package, when it detects CPUs, is saying each one of those cores is a CPU. All right? Follow with me here. So what we're doing is we're saying, okay, import the cluster package and then detect the number of CPUs that are available to us. And so the cluster package allows us to identify, are we on a master process, meaning are we on the original Node.js process? If we are, we want to, from there, fork that process. So we're going to create multiple running processes or multiple copies of Node.js to handle other requests. So the way that we create those is we create those based on the number of CPUs that we have available. So literally, if we had 3 cores, we would generate 3 forks of the Node.js process. So the cluster name's a little weird, but the idea is that we're creating 3 instances of our Node.js process. If we have 6 cores, like the computer that I'm on right now, we'll create 6 processes. If I have 8, we'll create 8 processes. So it's all contingent on the number of cores or CPUs that your computer you're running your code on has. So the idea is we create all of those forks, and then if we happen to be on a fork, well, we just handle the task at hand. So that takes a lot of thinking. That takes a lot of managing of this stuff. And if you're not experienced with it, it can be kind of burdensome. So what I decided to do was rely on this library called PM2. So PM2 is an advanced production process manager for Node.js. It sounds very serious. It is pretty serious, and it's pretty badass. So it does all kinds of stuff for managing a Node.js server in production. Highly recommend this. It simplifies the process of running one of these in production a hell of a lot, as well as it just makes the development process a lot easier too. So it's kind of multiple sides of it. So you can kind of see here, like, what I'm going to show you is this cluster mode thing, but it can also do hot reloads. It makes sure that if the server crashes, it'll try and reload it for you. So basically, you don't have to by hand manage all this stuff. Really great, and it's open source and free. Unless you want to use their monitoring tools, which are pretty neat, what I've looked at. So if you want to pay them, you can pay them. So that's what I'm using internally back here in the code. So before we talk about this specifically, what I want to show you is my package.json. So I've installed PM2 locally as well as globally on the machine. So when I say that, I mean I've done npm i save PM2, and I've also done npm i -g PM2. So that makes sure that it's on the machine that I'm running as well as a dependency of the project. So when I deploy this, it's going to run it on that machine, and it's going to know what the hell PM2 is. So the core piece to pay attention to here is this. So what I'm doing is I'm telling PM2 to be responsible for starting my server. So these are just npm scripts. So this is like me saying npm run development down here. This is just me making this line of commands a little bit more manageable. It's just giving me a shorthand command to run. So what I'm doing is I'm saying, PM2, I want you to start my server. And then this part is, and I want to say the -i in PM2 is instances, but the -i flag tells PM2 to start the server in cluster mode, which literally means all of the stuff we just looked at, we'll leave it alone, all the stuff we just looked at in the Node.js docs, it's going to do that for us. It's going to say, how many CPUs does this machine have? Okay, let me take the process that you've asked me to start. So in this case, this server.js file, which again is the actual starting of the job server that spins up Express and all of that stuff we looked at earlier. So it's going to start that, but it's going to start it for the maximum number of CPUs or cores that we have access to. So it's going to say, if you have 3, okay, I'll start 3. You have 6, I'll start 6. So again, this machine has 6 cores, so I'll get 6 running jobs. So it's going to do that, and then you'll notice that I'm also telling it to watch for changes. So it's not just going to start it and then exit, it's going to literally watch for changes. So what that means is it's going to restart the server whenever I change my code, which is really nice. So I get, just like I would with Meteor when I make a change to my code and then we see Meteor server restarted, this is enabling the exact same thing. It's saying if you change the code and the server is currently running, I'll just go ahead and restart it automatically. You won't have to stop and then start the server back up after every change yourself, which is really great. And then the final one is pretty self-explanatory. So this is me saying, which environment am I running PM2 in? So in this case, I'm running it in development mode. And this, if you remember from earlier, so we talked about, this is rolling the dice. We're just going to do it by hand. I was going to open it, but then I was probably going to like leak all of my keys to the internet, which wouldn't be fun. So that process, or this command right here, let me get my head screwed on tight here. Yeah, so when I say env development here, this is me telling PM2 to set this value to development. So that's how I know, oh, I'm running PM2 in development or staging or production. I manually have to tell it. So if you're going to do this, make sure that you do that, because that way it knows where it's running. So that's the actual starting of PM2. So that's PM2 running. And then you see I do an and. So what this is saying is run this command and then run this command. So PM2 monitor allows me to monitor the server or the servers that PM2 has started up. So what I mean by that is right now I'm running PM2, and you can see that again I have it's 0 index, but I have 6 servers running here. And again, that's because this computer has 6 cores, and I told PM2 when it starts to use the max. So let's go ahead and look at this. So I'm going to run PM2 stop all, which is literally going to stop all of the instances that it started. And then I'm going to run this command we just looked at. So I'm going to say npm run development. And so it starts the server, and then when all this neat stuff popped up, that was this PM2 monitor command. So it started it, and then it said, okay, now let's monitor it. So we can see that we've got each of these servers running, and this is telling us whether or not they're online and the amount of memory and CPU that they're currently using. Now you'll notice this will fluctuate. So just the natural occurrence of running a server is going to have stuff going on. So just because we're not sending this thing actual jobs right now doesn't mean that it's not going to run. So you'll notice those numbers will kind of hop a little bit. So the idea at play here is that when I start running this in production and I'm really sending it jobs, I'll be able to see which of those instances is using the most resources. So this is just a way to monitor, okay, what's the health of the application, or how well is it running? And then all of this other stuff, I don't really know what a lot of this means. I'm sure I could figure it out. It's not terribly important to me, but I also get some other information over here, like what's the name of the app, the version, how many restarts, what's the uptime. So every time the server restarts, that's resetting the uptime clock. And then it's also telling me like, where is this thing running? So it's just general monitoring information. So what's nice about this is this gets me all of the clustering support, which means the application will scale a little bit better. And it gets me monitoring all in one go, which is why I picked PM2. This was super nice. And this is my first time using it. So, and that should put it in your graces. So, I had heard about it before, but didn't really know what it was. And then a little bit of research told me about it, and it took me an afternoon to set up. It was really simple, really straightforward. So I highly recommend it if you've never heard of it. Or if you're going to do something like this job server yourself to try and leverage it. So one last thing I want to point out. So again, we talked about this command right here is saying PM2 start this based on the max number of cores that you have available, the max number of CPUs that you have available. So where did we go? Let's see here. See, this is what happens when I don't save my files. I forget where I'm going to... I'm going to say it was you. Yes. So I highlighted this, but I kind of skipped over it. So this whole cluster.isWorker thing, and let's just to make this loop nice and closed. Of course, I didn't remember. Cluster, Node.js cluster. Brain's shutting down already for the day. That's not good. So we've got this cluster package. So you'll notice here, I say if cluster.isMaster, and then there's this else statement right here. So this is if we were doing this by ourselves by hand. So over here, this if cluster.isWorker, that's saying, is this one of the spun up instances or one of the forks of the original process? So the reason I'm wrapping this code right here with that check is because if I don't, every time that the code is forked, I'm going to rerun my queue. So if I have 6 cores, I'm going to try and process my queue 6 times, which means all of my jobs get run 6 times. So if I have 100 jobs, I just created 600 instances of those jobs running, which I don't want to do. So by doing this check right here, what we're doing is we're saying, okay, if we're inside of a worker, meaning an individual worker, an individual CPU instance, go ahead and process that job. And so what that means is, okay, if we have multiple instances running and we have a bunch of jobs coming, well, because we're doing this processing on individual processors, the queue, so again, I use this package called Bull, and Bull is basically helping me manage the queue and define the queues and all that. Bull is always looking at the amount of resources that the process has. So if you think about that, it's the amount of resources that the server or the running instance of the application has. So if I have 6 cores, that's 6 different sets of resources. So basically, when I get a job in, if that core has enough resources, meaning it has enough memory, it has enough CPU, then the job is going to process. So if I send 6 jobs to this server all at once, generally speaking, they should all run all at the same time or simultaneously. I won't have to wait on 1 to finish, then go to 2, then go to 3, and so on. It'll just run them all simultaneously because it can. And so this check here is just saying, make sure that you're inside one of those workers so that you don't spawn a bunch of processing all at once. So that surprised me. I wasted a few hours trying to figure out, like, okay, why is this running all these times? And then I realized, oh, duh, right, you're rerunning the same code every single time that you fork the code. So that's what that's about, and that's what that's doing. So this has been kind of a whirlwind tour of how to define a job server. I don't want to kind of like understate that, yes, this is kind of difficult. This isn't the easiest thing in the world. But if you're building the type of application that's going to, run a bunch of tasks at once, and it might have a high amount of traffic, and some of those tasks are blocking, some of them are not. If you're in a situation where you just know inherently based on the design of the product that you're building that you're going to have a lot of resources that are required, highly consider this. If you're not, so I hopefully kind of explain it, but let's kind of wrap up here with this explanation. So the reason you wouldn't need this is if your application is just handling basic CRUD requests, meaning create, read, update, delete. So if you're just like having like an application with a form where the user fills out the form, hits submit, and then you put the result in the database, generally speaking, you're not going to need something like this. It's going to add more overhead than is necessary. Whereas in this case, I'm technically juggling multiple balls at once. So I've got the ball of, okay, I have to render this screen back to users. That's one type of request. They're going to have database traffic. So like if I add, we'll just say testing a new card, okay, I have to handle that type of work. And then I'm also having to handle these calculations. So whenever a new chunk of data comes in, I have to process that calculation, and I have to do it efficiently or quickly as possible. And so that necessitates more resources, which necessitates something that can handle that process independent of just normal user activity like this. Like if I just want to say, I want to add this is normal user activity, whereas I want those jobs to kind of run in the background while users are doing this. And the point being, again, Node.js is single-threaded, so I don't want to block users who are performing normal tasks from doing what they want to do because we're waiting on somebody's data to import. So that's the whole reasoning and logic behind why you would want something like this and why you would want to invest the time in getting it built. Because honestly, it's very purpose-built, but once you build it, you realize the value of it, and it makes scaling an application a hell of a lot easier. So again, I'm doing this before I go into production with this. And I'm the type of person who's very much against like premature optimization and things like that, but this is one of those situations where if I wouldn't have done this and I would have deployed the application, the first 2 people to try and do an import would have blocked each other and the app would have locked up and it would have been done. So I didn't have a choice here. So keep those things in mind, consider that, and if this sounds like something that you need, review this video, kind of take notes, and take the time to build it, because it will help you scale your application a little bit easier and remove a hell of a lot of headaches around managing crazy amounts of traffic coming to your application. And crazy amounts is relative, so I don't just mean crazy amounts like thousands or millions, like you would get at somewhere like a Twitter or Facebook, but crazy for your application. So like this application has to do a lot of processing. So crazy for me by default might be 100 requests coming in at once. So keep those things in mind. It's not, are you Facebook, are you some massive company, but does your product necessitate it and do you need it? So I'm going to wrap up here, folks. Hopefully that was helpful. Hopefully that was insightful. I really appreciate you watching. As always, if you haven't already, make sure to hit the subscribe button down below and then tap the bell right next to it to get notifications as soon as these come out every Friday. So again, thanks for watching. Signing off for the HMS Beagle. I'll see you next week.